So if I had the function f of x is equal to 3 over x minus 2. And I said, what is the vertical asymptote? What would you say? 2. So what makes the denominator 0? That's what we've been doing since grade 12, I guess. All right. So we know it's going to be x is equal to 2 because that's what makes you're dividing by 0. This graph looks like this. What's the horizontal asymptote here? We just did this. Sorry? I can't hear you. Infinity? Nope, there's a horizontal. 0, right? Because if you put infinity into... Yeah. Okay, so it would be 0. So you'd have a horizontal asymptote of 0. This graph looks like this. So can anybody tell me a definition of a vertical asymptote? It's tied to limits, since we're in the limits unit. If you're doing the limit of something, what happens as you go towards 2? What does the function do? Goes down or goes up to infinity, right? So the definition of a vertical asymptote is the limit as x goes to some constant equals plus or minus infinity. The horizontal is when x goes to positive or negative infinity. The vertical is when the y values go to positive or negative infinity. Now, you can ignore everything I'm about to tell you, okay, and just do it the old school way, because what I'm going to show you is how do you know if it goes to positive infinity or negative infinity, other than graphing it or plotting points or something. You can do that, okay? Like you could take this and go, I've got a vertical asymptote at 2. If I want to know, like, how do I know that the graphs don't draw this? It doesn't look like this, right? Why is it the other way around? You would test some points, all right? Now, the easiest point to test would be the y-intercept, but you could test some points. But if it's a more complex function that has multiple verticals and stuff like that, there's a little trick isn't the right word, but I learned it from an Italian professor who showed me this, which is actually kind of cool. So what you do is you go, okay, the limit as x goes to 2, that's our vertical asymptote. We know where that is. But we do one-sided limits. And we look at what happens to the function as you approach from the left and the right. Now this is where it's a little hand wavy, okay? Top is always going to be 3. The bottom, if I put 2 into this function, I get 0 in the denominator, right? Does everybody agree with that? Yes. Okay, so we write 0. But what I'm going to ask you, and I know 0 is neither positive or negative, we're going to pretend that it is for a sec here, okay? Because when you divide by 0, what do you always get? You get infinity. We have to figure out if it's positive or negative infinity, okay? If I'm coming towards 2 from the positive side, numbers that are bigger than infinity, is this bottom number going to be positive or negative? Positive, right? Because numbers that are bigger than 2, draw a number line. If I have, that didn't even go in, did it? So 2, I'm coming from this side, right? So just pick an easy number, 3. Okay? If I put a 3 into here, do I get a positive or negative number? Positive. So we say it's 0 plus. It's a positive 0. It's going to be 0, but it's always going to be a positive number. Now, if you're dividing a positive by a positive, you should get a positive, and the graph does go to positive infinity. If you do it on the other side, to negative, we know it's going to be 3 over 0, but we're coming at 2 from numbers that are smaller than it. So you could say 1.5. Sorry? No. 2 from the negative side. Remember, one-sided limit notation. All right. So we're coming at it from the left side, coming this way. So it's a 1.5. 1.5 minus 2 is I don't care what the number is, just tell me if it's positive or negative. Negative. So this would be a 0, negative. If you divide a positive number by a negative number, you get a negative infinity. So let's do a graph we don't know. Okay. F of x is equal to so we got 1 over x squared minus 25. So I want to know where the vertical asymptotes are. Heck, tell me the horizontal. So what's the horizontal? Let's start with that. Be 0, right? If you put infinity into there, you're going to get 1 over infinity, which is 0. Verticals. Where are my vertical asymptotes? 5 is one of them. And negative 5, right? Plus or minus 5. So and then we have y is equal to 0 as well. Okay. We could plot points, or we could do this quickly in our... Once you get good at this, this is faster, okay? So we need to look at the limits as x goes to our vertical asymptotes. So 5 from the positive and negative side. I know it's going to turn into 0 in the denominator. We just have to figure out if the denominator is always going to be positive or negative. So if I come at 5 from the positive side, so pick nice easy numbers, 6, okay? And I put a 6 in here. What's 6 squared? 36 minus 25. It gives me a positive number. So if we come from that side, we're going to positive infinity. So that means the graph looks like this. If we come at it from the negative side of 5, so you're coming this way. So 4 would be the natural easy one. So put 4 into there, what do I get? 16 minus 25, which is a negative number. So we're going to negative infinity.
Could you say that
No, because I can make one where it's not. So you do have to do this. If I just flip these to 25 minus, it would flip it. Okay. What did I say? Oh, so we come at 5 from the smaller side. We're going to the negative. Okay. We're just going to draw that bit of the graph. It's going to be like that. We got to figure out this one though. Okay, and not all graphs will look like that. There are graphs that you can cross through the origin because you can cross horizontal asymptotes. But we'll talk about that later when we do curve sketching. So if I want to know the other one, it's x goes to -5 from the positive, and x goes to -5 from the negative. Again, you know it's going to be 1 over 0, 1 over 0. We just need to know the positive or negative. Yes?
How did you know which one to choose?
What do you mean? How did I know which one to choose?
Look at the arrows.
Here?
Yeah.
So that's what this tells me, right?
But which one are you choosing?
This one was that, because we're coming at 5 from the positive side. This one is we're coming at 5 from the negative side. We're coming this way. Okay? So now we're going to test this one. So we're coming at -5 from the positive side, right? So that's this one. What number could I put in here? What would be a nice easy number? -1, or what would be an even easier number? 0 would be an easy number, right? It doesn't actually matter. But if I put 0 in there, do I get positive or negative? Negative. Yeah. So when you come this way, it goes to -infinity. So I know the graph is going to be like that. And then if you come at -5 from the negative side, so you put -6 in, -6 squared is 36 minus 25 is positive. So you get positive infinity. Okay, so you know it has to be like that. And yes, this graph has symmetry. That would have been a faster way to do it, but not all graphs will have symmetry, okay? All right, is that okay? It's a little weird. You're divided by 0 that is, we pretend is positive or negative, and it's giving us plus or minus infinity, but it's a quick technique. Look, you can always just plug some points in, and it'll tell you the answer, okay? But on a test, I will just write something like this. And I'll expect you to tell me if it's positive or negative infinity. Okay? That's what I will ask on a test. All right, here's your questions. There's not a lot of them. And we got one last thing to do, and then we're done with limits. So page 88, numbers 5, 7, 29, 31 kind of ties into what we did yesterday. And then 33 to 39. These are all only do the odds. And I think that's it. Yeah. Odd. And then we're going to do intermediate value theorem, which, as a friend of mine who has a PhD in math says, is the most important, one of the most important theorems in math. Exactly. Start. Okay, here we go. So, if f of x is continuous, okay, let's stop there. What does continuous mean? There's no holes, breaks, gaps, any of that stuff. On the closed interval AB, so that's your domain from A to B. And if you remember from Math 12, the square brackets mean you include the number, right? So that means we have a continuous function on the interval AB. So that means from A to B, our graph is continuous. There's no breaks or jumps. I don't care what happens outside of that. All right, but on that interval AB, it is a continuous graph. And K is between f of A and f of B. Well, f of A, this is essentially your y values, right? That's the function evaluated at A, which means this bit here would be f of a. And this bit up here would be f of b. They're just the y values if you put in these x values, because your domain is the x's. That's all it's saying. Okay? So we got some y values. That makes sense. We have a continuous function. And k is between f of a and f of b. So k is somewhere in here. That's all it says. K is between those two. All right, well, I'm just going to put k in there. There's my k value. Some other y value. And then what the intermediate value theorem says is there is one number, c, which we'll call c, between a and b such that f of c is equal to k, i.e., if this is k, then there has to be a number c that is between a and b such that if I put c into the function, I get k. That's all it's saying. This is super important because it will tell you if there are actual answers to certain problems. Some problems don't have answers. So you can waste your time trying to solve the answer, trying to find the answers, but there actually are no answers. Okay? The most basic that we will use it for, or that I will expect you to know what to do, is to prove that there is an actual zero or an x-intercept on a certain interval. Okay? So this is what you are responsible for. I would ask you a question like this. So show that f of x, which is x cubed plus 2x minus 1, has a 0. Remember, a 0 is an x-intercept. On the interval 0, 1. Okay? So I give you a question, and I say, here's your function, the cubic function. Show me that there is a 0, or an x-intercept between 0 and 1. That's what I'm asking for. All right? I don't care what it is. I truly don't. All right, that's a cubic function. Just like there's a quadratic formula, there's a cubic formula to solve this. If you can't factor it, I don't care about that. Your first step is there an actual answer? So your first thing is you look at the function, step 1. Is it continuous? Is this a continuous function? How do you know? Wild guess. There's no x in the denominator, i.e., it's a polynomial. All polynomial functions are continuous. So you can literally go, yes, because it's a polynomial. Okay, so we know it's continuous. That's the first part of the theorem. If f of x is continuous, you need to meet this criteria. Okay, so it's continuous. Then what you do is you find the value of the function at the endpoints over your domain. So step 2, find f of 0 and f of 1. What's f of 0? Minus 1. Everything disappears with an x. You're left with minus 1. F of 1 is 2. You put 1 in there, you'll get 2. All right. So we have a continuous function. We know at our endpoints, we have a negative number, -1, and a positive number. I'll graph this. So our interval is 0 to 1. At 0, we get -1. At 1, we get 2. This is just a visual. Okay, so there's my 2 points. It's a continuous function, which means what? There's no breaks, there's no holes, there's no gaps, there's no vertical asymptotes, there's none of that. So that means that the line has to connect to there, right? Does everybody agree with that?
Yeah.
Did I just prove there's an x-intercept? I did. It's there, because this is 1, right? So we've shown there has to be an x-intercept, at least one, between these 2 points. There could be more than one, it could curve back and go up, but there is at least one x-intercept. Okay? So, because f of 0 is negative and f of 1, I actually don't care what the numbers are. All you care about is one positive and one negative. Is positive, so this means negative VE, so it's like negative and positive I don't know why I write it that way, but I just do. And f of x is continuous. There must be at least 1, 0 on the interval 0 to 1. Or x-intercept, whatever you want to call it. All right, does that make sense? Okay, so you just need to show that the endpoints, you have a positive and a negative. You know, and you have to say the function is continuous. I got to do one more, and then we're done for the day. Then you can just say it must cross. All right, last question for the day. Show there is a 0 on the interval -2 to -0.5. It's not continuous, right? But where is it not continuous? X equals 1, right? Is 1 inside of our domain? No, so we don't care. That's what this bit says at the top. If it's continuous on the closed interval. So as long as it's continuous here, I don't care what happens there because that's irrelevant to us. Okay? So, not continuous at x equals 1, but that is outside of our domain. Therefore, I'm going to call it IVT, intermediate value theorem. IVT still applies. Okay, so then you just do the same thing we did. Not f of 0. F of -2. F of -0.5. Yeah, but then you would have to just say the intermediate value theorem doesn't apply either because it's not continuous. Because if it's not continuous, so if you look at this graph here, if the function isn't continuous, then that means it could do this. And you got those same 2 points. It could go like this, right? And then just jump like that, right? There's no x-intercept. That's why it has to be continuous, because then you know it has to cross. So if it's not continuous on your domain, you can say the IVT doesn't apply, therefore you can't show. Okay? Or you get 2 positive answers, but even then, I wouldn't do that to you, because you could just get 2 positives, but in the middle it could dip down, but I wouldn't do that to you. Okay? So if I put -2 into here, now I don't care about the number. I just care if it's positive or negative, so we can do this without thinking, or without doing a calculation, I meant, have to think. If I put -2 into here, am I get a positive or negative? Into the top, the square.
Oh, okay.
Positive, right? Plus a negative, which one's bigger? The square. So the top's always positive. -2 minus 1 is? So positive divided by a negative is negative. So that's always going to be negative. What's the other one? You can probably guess. It will be positive. So since 1 is positive, 1 is negative, and the function is continuous on our interval, right? Must be at least 1 x-intercept. All right. I will ask you a question like this on the test. All right. But basically, it'll just be like this. Here's your function. Does it have a 0 on some interval? Prove it to me. I don't care what the actual 0 is. That's irrelevant to me.
It does have a 0 when one is positive and one is negative.
Yeah.
Anything past that doesn't.
Well, it might, but we don't know. It's not continuous at x is equal to 1, right? Or it could have a hole as well. But we don't care about that. All I care about is on the interval. I don't care what happens outside of that.
If you get, let's say, if both of them were negative.
Then you can't say. Yeah, you'd have to say it's inconclusive since they're both below. It might, but you'd have to do a smaller interval to test it. Okay? But I'm not going to give you one like that. The only questions are 2 questions, page 80, sorry. Numbers 87 and 89. It's just practice doing this. That is it for limits. Tomorrow we will start